Good morning, my dear students. Today, in this video clip, I want to discuss about that is uniform circular motion. Now, what is the meaning of that is uniform circular motion? And before going to that point discussion, I want to request to all the students, you become a subscriber for our physics channel. How you become a subscriber? You press the subscriber button, red button, and you press the bell button, then you become a subscriber for our channel. Yes, I hope all of you become a subscriber. Now, I want to discuss about there is a uniform circular motion. Already you know this is a two-dimensional motion. Example for the two-dimensional motion. Projectile motion. Projectile motion is the two-dimensional motion of the particle. Now the uniform circular motion. What is the uniform circular motion? The uniform circular motion, it is also example for the two-dimensional motion. Example for two-dimensional motion. Uniform circular motion. What is the meaning of uniform circular motion? Any particle or a body move in a circular path. Any particle or a body move in a circular path with a constant speed, or is said to be with a constant angular velocity, angular speed, then it is said to be uniform circular motion. For example, rotating fan with the same speed, rotating fan with the same speed, rotating wheel with the same speed. That is the example for uniform circular motion. Uniform circular motion. Now see here, when a particle moves the uniform circular motion, when a particle moves the uniform circular motion here, now this is the center of the circular path. Now this is the center of the circular path. Now, the velocity at this point is in this direction. Velocity at this point in this direction. Velocity at this point in this direction. Velocity at this point in this direction. Fine. Now, the particle move with a constant speed, constant velocity, but their direction is changes at each and every point on the circular path of the motion of the particle. Velocity of the particle same constant. Anywhere that is its speed is constant. Not only there is the linear speed, but also angular speed is also constant. But that linear velocity, changes direction for each and every point. Changes direction. Here in this direction, then in this direction, in this direction, in this direction. Change in the direction. Due to change in the direction of the velocity, there is a acceleration. There is a acceleration produced in a particle, which the acceleration is always towards the center of the circular path. This acceleration is called a radial acceleration. This acceleration is called radial acceleration or centripetal acceleration. This acceleration is called radial acceleration or centripetal acceleration. The radial acceleration. Now it is a very important concept, the radial acceleration. In the radial acceleration, what is the meaning of radial acceleration? Any particle or a body move with a uniform circular motion, then that acceleration of the particle is always towards the center of the circular path. Towards the center of the circular path. This is called, what you say, radial acceleration or centripetal acceleration. Now, what is its direction? its direction is always toward the center of the circular path. Toward the center of the circular path, and its direction is always along the radius of the circular path. Along the radius of the circular path. Hence, this is also known as radial acceleration. This is the centripetal acceleration. And it is perpendicular to the direction of the radial acceleration, perpendicular to the tangent drawn at any point on the circular path. On the circular path, you draw the tangent at any point of the circular path, and that radial acceleration perpendicular to that tangent. Tangent. This is the direction of the radial acceleration. Now, a very important 5-mark derivation is there here. Carrying this 5 mark, derive the expression for the radial acceleration. Derive an equation of the radial acceleration. Equation of the radial acceleration. There is only change the direction of the velocity, but anywhere it is the constant. Constant means what? Constant means what? Now this the magnitude is same. At any point magnitude is same. Whether when a particle moves in from circular motion, its velocity is suppose 2 meters per second. Everywhere it is 2 meters per second only. Everywhere it is a 2 meters per second. When you derive the expression for the radial acceleration, one of the very important point, subtraction of the vector point is used here. Subtraction of vectors. Suppose, see here, I want to explain at this point here. Yes. Now, when a vector B is subtracting vector A, it gives the result vector C. Vector B is subtracting vector A, it gives the result vector C. How you represent graphically? It is very important. How you represent it graphically? What is the meaning of this? So this is the vector A. This is the vector A. Now this is the vector B. Vector B. Okay. Now you join this one. Which I have to join here like this. That is to join here. That is like this. Like this. Like this. Suppose you say this is the vector A. This is the vector A. This is the vector B. You join like this. You join like this. This gives the vector C, that is vector A minus vector B. Andre clear ಮಾಡೋದು vector B ನ vector A ದೊಳಗ ಕಳೆದ್ರೆ ಸಬ್ಟ್ರಾಕ್ಟ್ ಮಾಡಿದ್ರೆ ನಮಗೆ vector C ಸಿಗುತ್ತೆ ಅನ್ನೋದು ಹೆಂಗೆ ಅನ್ಕೊಂಡ್ರಿ? ಇವೆರಡು ಹೆಡ್ ನಿಂದ ಏನು ತೋರಿಸ್ಬೇಕು ಅಂದ್ರೆ ಯಾವ ವೆಕ್ಟರ್ ನಲ್ಲಿ ನಾವು ಕಳೀತಾ ಇದ್ದೇವೆ ಅದರ ಹೆಡ್ ಹೋಗಿ ತೋರಿಸ್ತಾರೆ. ಅದರ ಅರ್ಥ ಈ ವೆಕ್ಟರ್ ನಲ್ಲಿ ಈ ವೆಕ್ಟರ್ ಕಳೆದಿದ್ದೇವೆ, ಅವಾಗ ಈ ವೆಕ್ಟರ್ ಸಿಕ್ಕಿದೆ. Suppose ಇಲ್ಲಿ B ಇದ್ದು ಇಲ್ಲಿ A ಇದ್ದ ವೆಕ್ಟರ್ B ಮೈನಸ್ ವೆಕ್ಟರ್ A ಲೈಕ್ ದಟ್. ಯಾವ ವೆಕ್ಟರ್ ನಲ್ಲಿ ನಾವು ಕಳೀತಾ ಇದ್ದೇವೆ, ಯಾವ ವೆಕ್ಟರ್ ಕಳೀತಾ ಇದ್ದೇವೆ, ಅವು ಎರಡನೇ ಹೆಡ್ ಅನ್ನು ಏನು ಮಾಡ್ತೇವೆ? ಜಾಯಿನ್ ಮಾಡ್ತೇವೆ. ಯಾವ ವೆಕ್ಟರ್ ಕೂಡಿಸ್ತಲ್ಲ ಆ ವೆಕ್ಟರ್ ನಲ್ಲಿ ಈ ವೆಕ್ಟರ್ ಕಳೆದ್ರೆ ಈ ಜಾಯಿನ್ ಮಾಡಿದ ವೆಕ್ಟರ್ ಸಿಗುತ್ತೆ. That is said to be vector C. This is about subtraction of the vectors. Now this subtraction of the vector point is used in the derivation of that is in radial acceleration, or is said to be centripetal acceleration. Now see here, a particle moves with a uniform circular motion of the radius of the circular path r. Radius of the circular path r. Now at center C, radius r is equal to r dash is equal to r is equal to r. Now this is r dash. It is the position vector. This is r dash, vector r dash. This is vector r. This vector r dash. This is vector. Now you join these two. P dash. This is the vector delta. Vector delta is nothing but what to say? Vector r dash minus vector r. ಅಂದ್ರೆ ನಾವು ಇದನ್ನ ಕೂಡಿಸಿದ್ರೆ ಹೆಡ್ ಕೂಡಿಸಿದ್ರೆ ಇದರಲ್ಲಿ ಇದನ್ನು ಕಳೆದರೆ ಇದು ಸಿಗುತ್ತದೆ ಡೆಲ್ಟಾ ವೆಕ್ಟರ್ r dash minus vector r. when it is moved from point P to the P dash, it is moved from point P to the P dash. At point P, the velocity is vector v. At point P dash, the velocity is vector v dash. But magnitude is same. Modulus of the vector v, modulus of the vector v dash is equal. Suppose here 2 meter per second, here also 2 meter per second. But in this then, this is the direction of the initial and this is the direction of the final. But at any point the velocity is same. If it is 2 meter per second, anyway it is 2 meter per second. Okay, this is only change in the direction. Due to the change in the direction of the velocity, when a particle moves to uniform circular motion, the acceleration is produced. How you got the acceleration? Radial acceleration. You got the radial acceleration. It is mainly depending upon change in the direction of the velocity when the particle moves the uniform circular motion. This is very very important concept. Yes, fine. Now change in the velocity. Now here velocity v dash time, initial velocity v have to take. Now this magnitude is same but only direction is same. Now change in the velocity, vector v dash perpendicular to vector v. Now this is very important. Now this is the angle is delta theta. This angle is delta theta. This is the velocity v. This is the, we draw the parallel vector. And it is final velocity. This is vector v dash. Now you join these two delta v. Delta v is nothing but what? Vector v dash minus vector v. What is the direction here? How is the direction? Direction is like this. Change the direction. Along the radius. Along the radius, perpendicular to delta. Perpendicular to change the displacement. This is the perpendicular to. Now parallel to the radius, perpendicular to the delta. Now delta is r dash minus. Now you draw it. Now you draw here. This is AB parallel to PQ. AB parallel to PQ. Then AD parallel to P dash P dash. Angle BAD is equal to angle PCP dash equal to delta theta. Equal to delta theta. Now, average acceleration A bar is equal to delta V by delta T, equation number 1. This is average velocity, average acceleration you have to take. Change in the velocity divided by time taken. Total change in the velocity divided by. The limiting value of average acceleration is instantaneous acceleration. This is the limiting value of average acceleration. The limiting value of average acceleration is instantaneous acceleration. Instantaneous acceleration factor A is equal to limit of delta t tends to 0 delta v divided by delta t. Now its magnitude is given by A is equal to limit of delta t tends to 0 magnitude of the vector delta v divided by delta t. Yes. Now you come to the point. This is from the figure. You take the two triangles here. P, C, P dash and B, A, D. You take like this. These two are the similar triangles. One of the important property for similar triangles, the ratio of the sides are equal. They are not equal triangles, but they are the similar triangles. In the similar triangles, the ratio of the corresponding sides they are equal. I want to take here only two pair of sides. Now this is, in the case of similar triangles, one of the very very important property, ratio of the corresponding sides they are equal. Yes, BD corresponding side is BP dash. This is BD divided by AB. BD corresponding side PP dash divided by AB corresponding side is CP. This is CP. This one is CP. Therefore, BD is modulus of the delta. BD is modulus of vector V. Vector delta V. Modulus of the delta. Divided by AB is V. Only you take the magnitude here. It is not vector. Only sides. Sides you have to take. Sides means magnitude. Modulus of the vector is delta V divided by V. And PP dash is modulus of the delta divided by radius. CP is R here. R is nothing but R here. R is nothing but R here. If you want to take here R only, R equal to R dash equal to R. Delta V is equal to P you take in this side. Okay? P you take in this side. V divided by R is equal to delta R. Now equation 2 becomes. Now you substitute the change in the velocity delta V in this equation number 2. Now A is equal to limit of delta t tends to 0. V divided by R. Now this is you take delta R by delta t. What to substitute here? This is delta V is nothing but V divided by delta R, as it is delta t. Now this is A is equal to V by R. You apply the limit here. Once you apply the limit, now V by R is what? It is a uniform constant speed, and it is radius, it is constant. There is a change in delta. Now delta. The limit you apply the limit dr by dt is nothing but velocity, rate of change of displacement. Why you take the delta? Because it is a two-dimensional motion. Uniform circular motion of the particle is also called as a two-dimensional motion. It is also two-dimensional motion. Fine. Okay. Now this is that dr by dt is V. Therefore, A is equal to V by R. Dr by dt. This is V. This is the A is equal to V square by R. Now this is set to the equation number 2. This is the equation number 3. This is the equation number 4. And this is the equation number 5. Yes. One of the very important equation is the equation for the radial acceleration or centripetal acceleration. Is known the way equation of radial acceleration or centripetal acceleration. Yes, fine. What is the direction of the radial acceleration? The direction of the radial acceleration is along the radius of the circular path toward the center of the circular path and perpendicular to tangent drawn at any point on the circular path. This is the such direction of what you say, that is constant acceleration. Yes, this is the word radial acceleration. It is a very important concept. This one is a very important concept. Yes, what is the SI unit of radius? SI unit of radius is what? Meter. What is the SI unit of that is the angle radian. What is the unit of that is time? The SI unit of time is second. Yes. Now see here. Angular speed, linear speed, and relation between them. It is a very important concept. Once again, you can take here. This is the very important concept. Now, finally, you got the expression here. What you got here? A is equal to P by R, limit of delta t tends to 0, delta R by delta delta t. Okay. Now this is equal to P by R dr by dt. This is V by R to V. This V square is the expression for what? Radial acceleration. The equation for. Yes. Now we come to this point. Here. What do you want to see here? Yes. What do you got? That is angular speed, linear speed, and relation between them. A very important concept here, that angular speed, linear speed, and relation between them. Now see here. A particle moves in uniform circular motion. Uniform circular motion. Then a particle is moved from A to B, and is moved from A to B. It covered the linear displacement. It covered the linear displacement. Yes. It covered the linear displacement. Yes. ಅದು ಅಷ್ಟು linear displacement cover. Simultaneously, at the same time, it covered the angular displacement theta. ಏಕಕಾಲಕ್ಕೆ ಒಂದೇ ಸಮಯಕ್ಕೆ ಏಕಕಾಲಕ್ಕೆ ಎರಡು ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಕವರ್ ಮಾಡುತ್ತೆ. ಒಂದು ಲೀನಿಯರ್ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಕವರ್ ಮಾಡುತ್ತಾ, ಒಂದು ಆಂಗ್ಯುಲರ್ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಕವರ್ ಮಾಡುತ್ತೆ. ಈ ಚಾನ್ಸ್ ಪಾರ್ಟಿಕಲ್ ಸ್ಟ್ರೇಟ್ ಲೈನ್ ಮೂವ್ ಆಗುತ್ತಲ್ಲ, ಓನ್ಲಿ ದರ್ ಇಸ್ ಲೀನಿಯರ್ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್, ದರ್ ಇಸ್ ನೋ ಆಂಗ್ಯುಲರ್ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್. Two type displacement covered by the particle at the same time, it is only in the uniform circular motion. It is only in the uniform circular motion. Uniform circular motion. When it is moved from A to B, at that time it covers the linear displacement, and also it covers angular displacement simultaneously. That's fine. Now, linear speed. How we define linear speed? The rate of change of linear displacement. The rate of change of linear displacement is called linear velocity or linear speed. Now SI unit is meter per second. SI unit is meter per second. Simultaneously at the same time it covers the angular displacement. Therefore you define the angular velocity or the angular speed. The rate of change of angular displacement. The rate of change of angular displacement is called angular speed or angular velocity. Now SI unit is radian per second. Radian per second is the SI unit of the angular speed, angular velocity, angular velocity ಇರ್ತದೆ, linear velocity ಇರ್ತದೆ. ಅಂದ್ರೆ linear velocity, angular velocity ಎರಡು ಪಾಯಿಂಟ್ ಎಲ್ಲಿ ಬರ್ತಾವಲ್ರಿ? Only when the particle move with a uniform circular motion. Okay, what is the relation between them? Linear speed and angular speed. What is the relation between them? That is a very important thing. Now see here. You come to the point. Relation between R. R means AB and radius. Radius means R. Radius means R. And angle. Angle means theta. This S is equal to R theta. R theta. Suppose you take the radius R, small theta, R theta. Now V is equal to S by T. S by T. But S is equal to R theta. R theta by T. Now R into bucket theta by T. But theta by T is omega. Therefore V is equal to omega R. It is the relation between linear speed and angular speed. It is a very important point. The relation between linear speed and the angular speed. Now see here, in this video clip, I want to discuss about what is the meaning of uniform circular motion. Example, what is the meaning of radial acceleration? Then you obtain the expression for the radial acceleration. Very, very important. And also come to the point, the definition of linear speed, angular speed, and relation between them. The relation between angular speed and linear speed, this is P is equal to omega. Yes. One more point in the that is the uniform circular motion. You remember this one is, that is time period. Time period. T. What is the meaning of this? Time period. T. What is time period? When a particle moves to uniform circular motion, it complete number of rotations. When it complete one rotation, how much time is taken? That is time taken by the particle to complete one rotation, one revolution. This is called time period. Time period is nothing but it is the time taken to complete one revolution is called time taken. That is called time period. Suppose to take one example here. 10 rotations is completed. 10 rotations is completed in 20 seconds. 10 rotations completed in 20 seconds. What is the time taken for one rotation? 20 divided by 10. It means 2 seconds. 2 seconds. It means time taken divided by number of rotations. You think like it. It is measured in second only. Frequency. Yeah. How you write this one? Time period means what? The time taken by a particle to complete one revolution. This is called time period. What is the frequency? Number of revolutions completed, number of rotations completed in 1 second. This is called frequency. Under number of rotations divided by time taken. You take one example here. 10 rotations completed in 20 rotations completed in 10 that is 10 seconds. At that time, how you got this one? 2 rotations per second, RPS. 2 rotations per second. Number of rotations divided by time taken. This is the frequency. Once again, I repeat. Frequency means number of rotations completed by the particle in 1 second. This is called frequency. Time period is the time taken by a particle to complete one revolution is called time period. Now, frequency is equal to 1 divided by time taken divided by number of rotations. This time taken 1 by t. This is F is equal to 1 by t. F is equal to 1 by t or P is equal to 1 by F. Like it means what? It is measured in hertz, RPS, rotations per second, or hertz. This is measured in hertz, hertz. Hertz is the standard of this. What is the frequency? What is the? Now there are very two important definitions here. One is time period, another one is frequency. Once again I repeat, the time taken by the particle to complete one revolution or one rotation is called time period. Frequency means the number of rotations completed by the particle in 1 second is called frequency. Yes. Finally, I want to request to all the students to become a subscriber for our physics channel. If when you follow this one, if you like it, you share to other students and you press the like button. And first you have to become a subscriber for our channel. How you become a subscriber? You press the red color subscriber button and immediately bell button. Okay, then you become a subscriber. Okay, today in this video clip I want to discuss about uniform circular motion and example. What is the meaning of radial acceleration? And important derivation to obtain the expression for the radial acceleration, and you come to the point the linear speed and angular speed relation between them. And one more very important point we will explain here, that is time period and frequency. Yes, okay. I hope all of you become a subscriber for our physics channel. Okay, thank you. All of you become the subscriber for the physics channel. Okay, thank you.